excited to have you here for this session on AI agents with ML Chandigarh. It is my pleasure to introduce our speaker, Mr. Nitin Tiwari. Mr. Nitin is an associate data scientist at Colgate Palmolive India Limited and also a Google developer expert in machine learning with 4 plus years of experience in AI ML, specializing in developing end to end pipelines for applications focused on computer vision, NLP, LLMs, and generative AI. His expertise include JCP, Vertex AI, fine tuning LLMs, and deploying ML models. He has notable contributions that include projects and examples he has developed for the official TensorFlow.js and Gima Cookbook repositories, as well as his contribution to the Google Dev Library. Their expertise in the field of artificial intelligence and machine learning is sure to provide us with valuable insight today. Without further ado, please join me in welcoming Mr. Nitin Tiwari.
Well, thank you so much, Vanshika, for the extensive introduction. Hey all, good evening from Mumbai. My name is Nitin Tiwari and welcome to this session on AI agents. So I've been an old guest for ML Chandigarh, so I hope most of you already know me, but for those who don't know me yet, let me just again quickly introduce myself. So I'm an associate data scientist at Colgate Palmolive India Limited. So I work on ML-based solutions for them. Hey, good evening, Sagar. Apart from that, I've been a Google developer expert in machine learning for more than 3 years now. I've been contributing to a lot of open source projects. Some of them are like TensorFlow.js official repository and the Gemma cookbook. Gemma is nothing but the open source model from Google. Apart from that, I've been doing a lot of open source works as well. So yeah, let's talk about AI agents today, one of the most hottest topics in 2025. So okay, I'll just share my screen. And hopefully you can see this, right? All right. Yeah, so I've been a technical speaker as well. I've given more than 50 talks so far across India as well as internationally, and I'm a technical writer as well. So I regularly write technical articles on AI/ML on Medium. So do check out some of my works there. But coming back to the session, so today we'll be speaking about what AI agents are. So, just help me with a few things throughout the session. So if you have any queries or questions, then feel free to put in the chat. If you have any opinions, then again, feel free to put in the comments and I'll be glad to address them. Okay, so yeah, another rule is there's no good or bad questions. So the only bad questions are the ones that stay in your head. So if you have any queries, then just feel free to put in there. Okay, so coming back to this, we'll be talking about what AI agents are. Okay, the different types of AI agents. What is the hype of this agentic thing, happening on the social media? What is the buzz about it? We'll try to see that. And what are the architectures of a typical AI agent? What exactly form an AI agent? Okay, वो हम देखेंगे. Followed by some agentic frameworks that we have, the most popularly used ones. Okay, so as we progress in the session, we'll do some hands-on with small agents, which is a Hugging Face library for agentic systems, and then yeah, we'll see about Vertex AI agent builder as well. And at the fag end of the session, I have some resources for you. So if you have interest in this topic and you want to build more on this, then these resources will help you getting started with that. So just a quick question. How many of you who are attending the session are students? Can I just have something in the chat just to understand your bit? Yes, no, maybe. Okay. All right. So before we actually begin with the agentics, AI agents and agentic systems, let me just talk about what LLMs are. Okay. I hope most of you already know about what LLMs are these days. And let's see the evolution of LLM applications. So back in the year 2015, 2016, you might have seen examples on Gmail or any other email service provider. So whenever you type some email, you'll, for example, hi. comma, I hope. Okay, I hope के बाद you get some suggestions, right? कि you are doing well is the most predictable word in the sentence. So we started with with text completion. So the models, I'm not even talking about LLMs. These were small language models, or a typical general language model, which was able to predict words or sentences within the input text sequence. So we started with a very basic example, and then as the years progressed, we started with more complex applications of these language models, starting with the conversational chat. So conversational chat is nothing but a dialogue happening between you and the computer. So you might have done some reasoning or questioning on ChatGPT or Gemini, right? Can you help me with this question, or can you help me plan a trip, right? And the models that we are using, these are able to retain the context. So let's say you are asking a sequence of questions, and then the model keeps on replying to those questions. So if you go back to the previous question, the model still has the memory key, what was the conversation, so it retains those contexts. After this, we had some models which were able to follow the instructions. So these instructions could be anything. For example, you have a big chunk of text that you are not able to understand. For example, if you are reading a technical paper and you want that to be summarized into very simple words, you can always ask the model ki, hey, can you just summarize this piece of text for me? Let's say you have a question कि कुछ उसमें text समझ नहीं आ रहा, so you want some clarification. So you can also question the model कि can you just tell me what exactly this sentence means in this particular piece of text. So these are nothing but instruction based models. Let me give you another example. Let's say you visit a foreign country and you see a signboard with some native language, okay, which is not English. So how do you go about it? How do you know कि उधर क्या लिखा है? So what you might have done, click a picture of that, use Google Lens or Google Translator, and then feed in the input, and then you'll get the output. So based on the instructions that you provide, these models are able to do those tasks. So these models are quite versatile in nature. Then came the vision language models, or models with vision capabilities. Okay, VLMs and diffuser models are different. Okay, so VLMs, what they do, they have the capabilities to understand the you know content within an image or videos. Similarly, diffusion models, these are text to image kind of models. So where you provide a piece of text and then you ask the model, hey, can you just generate this image for me with all these features? And then finally, we are talking a lot about AI agents in 2025 already. It's still the first month of 2025, and we are seeing a lot of you know tutorials and blogs and a lot of buzz happening on social media and LinkedIn. So what these AI agents do actually? So, these models, they don't just give you the output, but also perform some tasks on your behalf. So they perform autonomous tasks and integrate with external environments. Okay, we'll understand this with the help of very, very simple example. And since most of us are students here, I hope you'll be able to relate with this. So let me ask you one question. How do you solve your assignments? The assignments that is given in your college or university, how do you go about it? Can someone put in the chat? I just want to know. Okay, if you are quite shy, then let me, yeah, chat GPT, very honest answers. That was what I was expecting. So if I just lay this down, this is all you are doing, and I know very well. You first click a picture of the assignment or whatever image was circulated in your WhatsApp group of your class. Okay? If it was a PDF, you'll just download it, and then you will upload it on Gemini or ChatGPT or whatever language model you are using, whatever services you are using. Okay, hey, this is my university assignment, and please solve this for me. My grades are at risk. So that is the thing. Step two. Step three, you'll get some response from the model based on the questions that was present in the PDF or image, whatever you had supplied as an input. Step four, you won't just copy the answers. Okay, you'll have to make some edits, right? You don't want to feel your professor ki अपने पूरा internet से छापा है answers. So we'll do some edits. We'll make sure कि it looks like human generated responses, and then finally we'll turn in your assignment. So depending upon whatever your college asks for, whether it's a portal where you need to submit your assignment, or whether it's ask from your professor, you just send an email of that PDF or whatever document you have prepared. So this is how you must be doing it, right? Okay, Sagar has recently used Black Box. I haven't heard about it, but okay. Okay, you are doing this well. But then suddenly there's a twist in the tale. Your instructor or whatever your professor, he just pings you on WhatsApp late at midnight. Ki, thanks for submitting this, but I will not review your assignment. I'm declining your submission. The reason is the answers that you had used in the assignment, it was just vaguely out of the knowledge that the LLM had. मतलब जो भी model train हुआ था, whatever language model we had used, whether it was Gemini or ChatGPT, the answers were based on the words or the choice of sentences on which the model was trained for. Okay, but you see some examples right in your real life world as well. Ki there are some professors who expect ki whatever notes they provide, the answers should match those keywords or terms. They have some ego issues sometimes. So yeah, what do? You just plead your professor ki please accept it this time, and I'll make sure ki I'll use your notes next time onwards. Okay. But then the thing is, all the work that you have done, जो भी आपने मेहनत किया था, it goes in vain. You have to do all the tasks yourself once again, right from feeding the input to the model, then getting the answers, then choosing which one is correct, which one is incorrect, what needs to be edited, then creating a PDF out of it, and then sending the email once again. So this is a time-consuming process, right? But what if there is a system that will do all these tasks for you, and you don't have to do anything? You just have to supply the input. So the model or whatever the system that we are talking about, it will be able to do RAG. RAG is nothing but retrieval augmented generation. So RAG is nothing but whenever we expose the model to some external data, apart from the knowledge that it had of its own, that is nothing but RAG. Okay. So we'll do RAG, and then the second step is reasoning to answer those questions. Whatever questions were listed in the assignment, the model will try to reason and give some answers. Step three will be to verify the answers so that you don't have to go back and then edit the responses yourself, like in step four here, as mentioned. And once the answers are verified, you create a PDF of final PDF that can be submitted, and then send an email to your professor. So we have a system called as AI agents for that. Okay, so that's nothing but AI agents in simple words or in simple language. So whatever buzzword that you hear these days on LinkedIn or whatever social media platforms you are following, AI agents का काम ही है कि they just use these LLMs and then perform some autonomous tasks. Okay, so just to put in formal definitions, now I hope you might have understood the basics of what AI agents are. If I just put this in formal definitions, then these are the systems or autonomous systems designed to perform certain tasks and make decisions on their own, okay, with the help of LLMs or any other AI technologies. So it's not necessarily we always use LLMs. It can be vision language models as well. It can be any other computer vision based or deep learning based model. But these days we are talking a lot about generative AI, so that's why LLMs. Okay. And yeah, in simple words, AI agents are nothing but the programs where LLM outputs control the workflow. So it's not just you giving the input, getting the output from the LLM, and then the work happens. It also perform the tasks. Okay, so okay, let's try to understand the architecture as well. So since we are engineers, we should know the working behind each of these systems. So any AI agent or any AI agent that you come across, you'll see these components. First is the LLM, the most important part, which acts as the brain of the agentic system that we are working on. Okay. So these LLMs can be anything. It can be any model, like for example, Gemini, Gemma, Llama, Quen, etc. Okay. So it can be any language model that we are using. Then there is something called as memory. So memory, what it does is it's basically a storage space within the agentic system. Where what it does is it basically stores the previous responses of the LLM. Okay. So let's say you are asking a sequence of questions to the model and you get some responses, but the model still recognizes or is able to understand the context based on whatever we had asked in the past. So that is nothing but memory. वहाँ पे वो स्टोर करके रखता है and इसका यूज क्या है, I'll let you know. ठीक है. Then the third important thing or the component that we see in the architecture is tools. So tools can be anything. It can be any external environment that allows the language model to get data apart from the knowledge that it had of its own. Okay. So these tools can be web browser, it can be a search engine, it can be an API or any other custom functions that you write it yourself. Okay. If it is still not clear, don't worry, I'll give you a very good example. But just try to remember these three or four things. Okay. And then we have something called as uh, executing the next step. इसका भी काम क्या है, let you know. ठीक है, so with the help of an example, let's try to see this. Okay, so there is a use case कि we tell the LLM कि you are a meteorologist. Meteorologist is the one that has the understanding of weathers and climates and all those stuff. System prompt is nothing but we are setting a template or we are just setting a background and telling the model कि you are an expert in this particular thing, and yeah, you make use of Python and web search to predict tomorrow's temperature. You are free to use any open source data available. See, just pay attention on this. I'm talking about open source data. Although the LLM is already trained on a lot of data, right? And then answer the questions that I'll be giving to you. So this is the system prompt. So any typical LLM that we are using behind the scenes, whoever is the developer of that particular language model. For example, Gemini ka developer is Google. ठीक है? Llama is maintained by Meta. So all these models will have a default prompt which is hidden from us. That is nothing but the system prompt. Okay. And then here's the actual prompt that we give as a user. So as a user, I say the model ki predict tomorrow's temperature in Chandigarh. Okay. So that goes in as my prompt. So prompt is nothing but system prompt in the very first step because the memory is empty. Whenever I'm initiating a conversation, initially the memory will be empty, right? Because that's the very first question that I'm putting in to the LLM. So whatever prompt I'll give, the LLM will give some output based on that. For example, it can be fetching the weather data, it can be training the model or searching for anomalies, and then it will go through a process called as parsing tool, okay, based on the output that it receives. So parsing tools is nothing but it's a function. It can be a API or any other thing that allows the output to be processed. The post processing of output takes place. And based on the answers that we have after going through this step, if it is correct, that will become my final output. For example, if the answer is tomorrow's predicted temperature in Chandigarh is 25 degrees Celsius, then it will give me as the final output. But let's say the model hallucinates and it says, out of the box key, out of the blue की मेरा चंडीगढ़ में in January 25th, ठीक है, आज के दिन पे the temperature is 60 degrees Celsius. So does that make any sense? No, right? In winter 60 degrees Celsius, 60 तो कभी जाएगा नहीं इंडिया में, first of all. So that's a case of hallucination. So what the model does is it will execute the next step. It will again do the same thing, but this time it has the memory. It has the memory like जो false answer था 60 degrees Celsius वो नहीं होना चाहिए next time onwards. So again that goes into the prompt. This time my prompt becomes the system prompt plus the prompt that I had provided and whatever was stored in the memory. Again it does all those steps again. Finally it processes the output and the final answer मिल जाएगा. Once it feels that the answer is correct, that becomes my final output. So this is how agentic systems work on a very high level. I just try to simplify this with the help of this diagram. Next, let's learn about different types of AI agents. Okay, so AI agents can be of two types. It can be React agent. So when I say React, React is nothing but reasoning plus acting, and it does this thing iteratively. So uh, what it does is, let's say I have a task to do. It will break down those tasks into multiple subtasks based on whatever I need to do. For example, some kind of reasoning and then doing some actions based on that. Whatever the intermediate results were given by the LLM. Second kind of model is, or second kind of agentic system is the code agent. So what the code agent does is it will pre-plan all the stuff right at the beginning beforehand, and then it will generate a Python code and then execute those steps all at once. So you don't have to iteratively do things. So जो भी सब कुछ रहेगा planning करके it will do the execution. So this is nothing but code agent. And if it is still not clear, we'll see some examples. So don't worry about that. Next is agentic systems. Okay, so agentic systems can be single agent system and it can be multi-agent systems. So as the name suggests, single agent system are those systems uh, where there is only a single agent managing all the tasks. And multi-agent systems, again, as it says, there are multiple agents working in tandem to solve some problems. If I were to give you one example, okay, let's say you're working in a company and there is a client who is asking you to develop a website for them. Okay, so to develop a typical website, we need three things or three teams, right? One is the front end team that will work on the look and feel of the website, the UI and UX, all those stuff. There will be a backend team which will be working on database and integration. And finally, there will be a testing team which will test all the integrations and whether the website is working or whether it is breaking at some stage and all those stuff. So you can just correlate this example with multi-agent systems. So the three agents in that case will become as front-end team, the back-end team, and the testing team. And all these three work together to solve the bigger problem, which is nothing but developing and delivering the website. Okay. Uh, okay. So this is the difference between the React agent and code agent again, with the help of an example. So let's say I want to book a flight from Mumbai to Chandigarh for today, and I want the cheapest flight. So what the React agent will do, it will do some reasoning. Reasoning is just trying to understand कि मुझे करना क्या है. ठीक है? The first step will be to check all the available flights from Mumbai to Chandigarh for this particular date. Reasoning कर लिया, then it will do some action. Action क्या होगा कि it will query the flight search API for flights on 25th Jan. So action is nothing but it will do some kind of browsing कि Indigo is available या फिर any other airline is available, and it will get the list of all the flights with all the details कि airlines कौन सी है, prices क्या है, timings क्या है, and so on. ठीक है. One step is done, then it moves on with the next step. अब next step क्या है, एक बार मुझे list मिल गया, I'll just try to find which is the cheapest one. Cheapest one is nothing but I'll just sort the list based on the prices, and then I'll do some action. Action is nothing but processing the data. Okay. And then once the cheapest flight is identified, it will then go ahead with the next step, which is booking the flight itself, flight ticket itself. So to book the flight ticket, it will call an API, a booking API. It can be anything. Okay, Go IBO या फिर any other booking services available, and then finally the flight ticket is booked for you. So you see, if you break down this entire thing, it will do reasoning and then acting on that reasoning at every step. That's why we call it as React agent. And if we compare it with the code agent क्या करेगा? It will beforehand think of all the steps, all the possible steps that I need to do to book this particular ticket, and it will execute that Python code finally, and that's it. So it does not have to think again and again कि चलो step one हो गया, step two में क्या करना है, step two हो गया, step three में क्या करना है. So it will just generate all the code for you, just in a single go, and then execute that thing for you. Okay, I hope so far so clear. If you have any queries or questions, then feel free to put in the chat. If not, then we can just move ahead. Okay, so let's talk about some most commonly used AI agent frameworks. So you will see some blogs or posts on LinkedIn or Twitter. A lot of blogs talk about Hugging Face small agents. Then the Vertex AI agent builder from Google. You'll see some examples from Crew AI as well. So buzzing AI agent framework these days, along with Pydantic and LangGraph or LangChain. So I'll not be talking about all of this today, but we'll be mainly focusing on the first two, the Hugging Face small agents framework and the Vertex AI agent builder. We'll be doing our hands dirty on small agents, and if time permits, we'll also be doing some practical hands-on with AI agent, sorry, Vertex AI agent builder. Okay, and if you honestly ask me, I haven't tried all of these. I've just tried the first two. So okay, let's get started with this Hugging Face small agents. Again, why small agents? So small agents, as the name suggests, the word small itself, speaks volume. Ki small is nothing but the library that was maintained by the Hugging Face team for this particular thing. It's quite small in nature, only 1,000 lines of code to handle everything. And small agents are nothing but small agents are nothing but task I need to do. Okay, so we'll see some examples. थोड़ा उससे और clear होगा. Uh, Apart from this, small agent has support for both open models. Open models are nothing but the models which are free to use, which are available on Hugging Face Hub, as well as proprietary models like Gemini, OpenAI's GPT models, Anthropic's cloud models, and other models as well. So proprietary models are those for which you need a API key, or for which you have to have a subscription for. And Light LLM is one of the libraries or service provider which provides integration for all these closed source models. Hugging Face also has some built-in tools like DuckDuckGo. You might have heard about this DuckDuckGo search engine, right? Just like Google search. So with the help of this, we'll be doing some grounding. Grounding is nothing but the technique of exposing the model to the real world or the external data. And it also has integration with LangChain and Hugging Face spaces. And if you ask me how to use small agents, it's just merely three lines of code. First, just import the library. Second, initialize the agent, the code agent here. Tools में it will be a parameter कि कौन सा tools आपको use करना है, and then the model, whatever model is, ठीक है, whether it is Gemini, Gemma, and so on. Finally, you run the agent with what task you need to do. So, for example, in this case, I'm asking it to create a fictional story or a fictional alternate ending to the Harry Potter and Chamber of Secrets movie where Tom Riddle wins instead of Harry himself. Okay. So let's get started. You can just follow me along. The only prerequisite is you must have a Hugging Face account and a Hugging Face token with read write access. If you don't have it already, then no worries. You can just follow me along. If you have, then uh, okay, that's well then in that case. So we'll be doing some small projects. We'll be creating our very first AI agent today, followed by doing some kind of grounding with web search engine, and then we'll see some vision-based use cases as well for this. And there's a very interesting use case here that I've added. I was working on this for the past few days, and finally, I'll be happy to show this. Okay, so just a disclaimer: don't use this in your real, life. Otherwise, you'll get fired. But anyways, let's see. You can just clone this repository or just directly go on this repo. Okay, once you go to this website, you will or this repository, you'll find a collab notebook here present. Just click on this open in collab link or the button. Make sure you are connected to your Gmail account because to use collab, we need the Gmail account for that. Okay, so once you are connected, then we start with importing the or installing the libraries. We'll be starting with small agents, small agents light LLM. I've included Gradio as well just in case. And these are some external libraries that we'll be using. Okay? But the most important one is the small agent and small agents light LLM. Yeah. So we just start by executing this cell. Okay, how many of you follow cricket or watch cricket? Can you just put in the chat? Can someone tell me when was the last time India won the T20 World Cup and against which team? Okay, any guesses? Okay, Okay, Ronnie says it was in the year 2024 and against South Africa. That's perfect. Yeah, but if I ask the same question to ChatGPT, let's say, okay, let's ask this question. When was the last time? And it says ki it was the year 2007 against Pakistan. It's a very old information and seems like the model is not trained on the latest data. Okay, so this is a false information that the model is giving, and it's quite risky if we just blindly use any output that the model gives. So what ideally we need to do is we need to do some kind of grounding. Grounding is nothing but exposing the model to the real world data. For some reason, I got some error. Let me just open another instance of Colab. Okay, meanwhile, I'll just ask Gemini as well the same question. Just copy paste. Okay, just for comparison's sake, even this model is okay. Yeah, even this model is giving me incorrect answer. Okay, so while this gets installed, what you have to do is the second step is to clone the repository, which is available here by just running this cell. If you already have a Hugging Face token, which is saved in your Collab secrets, then just run this cell. If you don't have it saved here, then this is an alternative way to log into Hugging Face account. So since I already have this saved here, I'll just run this cell. Additionally, what I'm doing here is I'm also configuring my Gemini API key because we'll be using this in the examples that we'll be seeing. Okay, so let's start with a very simple example of creating a very basic agentic system or agent. So how do we start? We just start with importing some libraries, which is nothing but HF API model. Okay. This library, what it does is it will help me understand which model is I'm going to be using in my agent. And second is the type of agent, which is nothing but code agent. So throughout the session, we'll be using code agent and HF API model. And by default, if you don't provide any parameter to this, by default, it will consider this model. Okay. And I'm asking the same question to this. If you see, there's another parameter called as tools, which is blank for now. So this means that I'm just using the model's own knowledge for answering this question. Okay, and let's see the answer. The last time India won the T20 World Cup was against England. In fact, England was the team that beat India in 2022 in the semi-final. So this is incorrect. But if I just, use some kind of tool, which is nothing but the DuckDuckGo search engine. Okay, this is a built-in tool provided by Hugging Face Small Agents. Okay, I'll keep everything same, just that I'll just add these tools here. Okay, by importing this, I'll keep the prompt same and run the cell. Then let's see if it is able to correct. So you see behind the scenes what it is doing. Since this is a search engine tool, what it is doing is it is going through or crawling through all the websites or web pages. It is grabbing or gathering the information. For example, there was one article on this website that said ki India, ended a 13-year long wait and finally won the World Cup. And finally, it goes through all the other websites as well. Finally, it gives you the answer ki, hey, yes, India last won the World Cup in 2021 against South Africa. Again, this is incorrect, but you see, this is partially correct. इस बार उसने South Africa बोला. That is correct, but here is wrong. So let me just try to use another model. Let me just run this cell again. Let's see. Yeah. So this time it correctly said कि last time was 2024 when India won the World Cup. And it is against South Africa. So you see the difference when I use a tool instead of the LLM's own knowledge, right? So this is how you can use tools. Now let's do some more complex examples. Okay, so how does a virtual assistant like Siri work? I'll just give a vague or very simple high level breakdown of the problem. So whenever you ask something, can you just play this song for me? It's basically a speech recognition kind of task where you're asking the model or you're asking the assistant, can you just play this song for me? So behind the scenes, what it is doing is it is extracting that audio, it is converting it into text, trying to find some information, and then it does some query in the database, whether I need to play this song or whether I need to set this alarm. Okay, and then finally it does that action for you. So that's how these agentic systems work. So similarly, there is some another example that I can give you, the autonomous vehicles. So what they do is they have the vision capabilities to understand whether the traffic signal is red or whether a pedestrian is walking across the street, and if any of these conditions are meeting, then it will apply the brakes. So this is how these agentic systems work. That was just a high level explanation of that. Next is we can just use a proprietary model now instead of using any open model. Okay, so this was an open model available on Hugging Face, the Quen 2.5 coder model. But if I want to use another model, as you saw, when I first ran this, it gave me incorrect response. The last time India won the World Cup was the year 2021. फिर से उसको run किया, then it gave me the correct answer. But that's not how I want it to be. Okay, so I'll be using a better model in this case, which is nothing but Gemini. Okay, so I'll also pass an image in this case. Okay, we'll do some complex examples. So if you see the repository, it has a image here. Okay, a sample image. I'm just loading it using PIL. And this time, it's not my HF API model. I'm using the light LLM model in this case. Okay, where I pass in the model ID, which is nothing but the latest Gemini 2.0 Flash experimental model, and I'm passing my API key because to use Gemini, I need an API key, right? The rest of the things remain the same. The tools I'll be using is this. I don't even need a tool because I'm just trying to tell the model, can you describe this image for me? So if I just remove this, it will not make any difference. This is basically an image of street in Budapest. You can see some cars and buildings. And this is the response. It depicts a charming European street. Yes, it's a European street with cobblestones and buildings and so on. Okay. So if you see, it has described this image so precisely and so detailed. It has given all the details, whatever is present in the image. So these models are able to handle image capabilities as well. Now let's come to the very interesting use case, okay, where we'll be solving an assignment. Okay. Let me just show what kind of assignment we are talking about. So if you see the repository, it has a science class 10 textbook. Okay, I just randomly picked some examples. Let me just show you the content. So this is an NCRT textbook for class 10. The chapter is chemical reactions and equations. It has some diagrams and some sort of chemical reactions and other stuff. Okay. So what I'm doing is I'm doing a lot of other stuff as well. So additional thing that you will see in this import statement is the tool one. So instead of using the DuckDuckGo search tool, which is the built-in tool, I can create my own tool as well, right? I can just create my custom tools. So all you have to do is you have to just write a function. You can describe a function with some text key what exactly this function does. Okay, what kind of arguments it accepts. So for example, read PDF file is one of the functions that I had defined, and you have to use this at the tool decorator so that the small agents library understands that this is a tool now. So this function will act as a tool. Okay. Another tool I created was send email. So we have two tools here. One tool will be responsible to read the PDF file, this entire PDF file. The second tool will send an email. Okay. So again, I'll be using Gemini because it has a bigger context window. This time the tools are the two functions that I had defined. The model remains the same. And if you see, there is an additional authorized imports parameter that I'm using. So this is nothing but the external libraries that the model will be using or the agentic system will be using. So PyPDF to read the PDF, and docx is used to write the assignment or whatever answers it had in a document or Word file. And this becomes my actual prompt. Please load the source file. The source file is present here, base path के अंदर science class x PDF. I'm asking ki, can you just help me with these three questions? What is the chemical formula of magnesium oxide? I just go up. I just saw somewhere ki magnesium oxide is this. Yeah. Okay. MgO is the formula. List the different daily life examples given in the PDF and summarize what is the chapter about. Different life examples I saw here. So these are some random questions I just picked. You can feel free to play around with this. Apart from listing the questions, what I'm also asking the agentic system to do for me is save the answers in a doc file in the current directory using this library. Additionally, write my details such as, let me replace this with my own name. I still remember my roll number from my engineering days. Subject name मैंने model पे छोड़ दिया है to understand कि which subject this is. So we as humans know कि this is a science subject, but let the model understand or handle that. Submission date, I have purposely written today's date so that the model can, just interpret कि आज का दिन कौन सा है by using some libraries. Then another piece of text I'm providing to the model is कि just provide an undertaking that says कि all of this work is my own. Okay. And then finally send me an email of the saved document as an attachment to, let's say, it sends this uh, assignment email to me as well as, let's say, for the ML Chandigarh team as well. Let me run this. So you see, this is a code agent, and behind the scenes, it is executing this code. So first, it read the PDF file. This is the content it has read. Then the next instruction I had provided key, just write all the answers in the form of a document, okay, or a Word file. And then finally, the assignment was sent. If I just open my email, pretty well. So this is the assignment that it has sent. So not only it just gave me correct answers, MgO was the correct chemical formula, but also it, precisely formatted the document for me with all the details like what is my name, what is my roll number, subject, submission date, and so on. And see, it has also sent an email. So that's how agentic systems work. That was what I wanted to show you. And yeah, so this is a pretty cool example of how agent systems work. And then let's move ahead with another example. So in this case, we'll ask the model to behave as a data analyst. Okay, I have a data set of some, IPL matches. You can just check it out here. It's a CSV file which has some columns like what is the season of that, IPL tournament, what city was the match happening, the teams, and so on. Who was the winner? What was the statistics and so on. So again, I'm asking the model ki just load this source file and answer some questions based on it. How many matches did India, or sorry, Mumbai Indians win in that tournament? Then which team won the most number of matches, or which team won by highest number of runs? What was the date? And which were the two teams between which the match was played? And other questions as well. Okay. I'm also asking the model to run some kind of visualizations with the help of tools like bar chart or pie chart, okay, or matplotlib as a library. and the execution starts. So it starts with importing the library. In this case, it is pandas, which is used to process the CSV files in the form of data frames. Okay, and see, so it has executed this quite perfectly. These are the results. If I just try to open this, if I just do a sort or filter on this winners column, so the count is 109 if I exclude the header. And this is the answer from the model as well, that Mumbai Indians has won exactly 109 matches in the data set provided. So not only it gave me the correct answers, but also it plotted based on the instructions that I have provided. It gave me some charts and then it saved it as an image here. So yeah, this is how you can use AI agents for solving some, you know, day-to-day tasks like these. There is another example that I wanted to show. So in this case, we are importing a Hugging Face space as a tool itself. Okay, so whatever Hugging Face spaces are available, you can also make, use of them as a tool. So I'm using this Black Forest Labs Flux Point 1 dev as the text to image model here. I'm providing a prompt. The model remains the same here. The code agent model here in this case. The libraries I'm going to use is PIL, of course, because I'm talking about images. And the prompt I have given here is improve this prompt and generate its image and save a copy of it in the current directory, and save the image as a .jpg file using this library. This is my prompt, cherry blossom in Japan. So it takes some time to run because in the backend it's trying to execute or integrate with this Hugging Face space. So this was my prompt, cherry blossom in Japan, just a simple plain prompt, and this is the improved prompt as I had instructed the model to do, which is quite detailed. Then it goes to this model with the integration of Hugging Face spaces as the tool here. So if I just enter the same prompt and click on run, the image will be generated. The same thing is happening with the help of agent here. And you see, I was talking about some steps in my architecture, right? If I just go back, yeah. So I was describing key, let's say if the model fails for some reason, it will again go back. It will just try to execute the same thing again until the response is correct or until the end result is met. So this is what is happening here as well. So if it fails, it will again go back. It will try to execute the next step and so on. Okay. Meanwhile, if you have any questions or queries, then feel free to put in the chat. Okay. Can you suggest some use cases of AI agents? We can have it in healthcare as well as financial, companies or industries where they need to do a lot of data processing. So with the help of tools like the tools that we build ourselves, like data pipelines using pandas and all those stuff, We can make use of agents in that case just to solve those tasks for us and make our lives easy. Can an AI agent learn from its mistake? That's what is happening here. Because if you see, if the given output is incorrect, it again goes back, it stores it in the memory. Next time I don't want to display this thing as the output. Okay, so it learns and then it again goes into the model, it gives the output. Again, the verification happens and finally the final output is given. So this happens in the in a loop. Okay, I hope the code is executed. If I just open this cherryblossom.jpg, this is the image generated by the model. Not quite realistic, but yeah, good enough. So these are certain use cases where you can use AI agent systems or Hugging Face small agents to work on image-based tasks or textual-based reasonings. If you have a CSV file, if you want to solve an assignment, you can do this. You can send an email. Okay, so let's talk about Vertex AI Agent Builder. I just wanted to show quick uh, walkthrough of this as well, although we don't have enough time. But yeah, Vertex AI Agent Builder is nothing but it's a no-code tool from GCP or Google Cloud Platform where you can build AI agentic systems or apps. It supports data in different formats. It can be unstructured data or structured data as well. And it has integration with different third-party data sources as well, which can be Jira or Salesforce or ServiceNow and so on. So having been worked in the IT industry, I know how these tools work. So we have Jira for keeping track of incidents and the tasks that we work on day-to-day basis. So Vertex AI Agent Builder helps you to integrate with these tools to simplify the process. And some of the app templates supported by the Vertex AI Agent Builder are you can do a web search, okay, with the help of these tools, document search, media search. Media search is nothing but searching with the help of images or videos, and detailed search. While you can also have conversational agents like Dialogflow, which is a chat app service within Vertex AI. Okay. Okay. So the very first step is you have to go to Google Cloud Storage and create a bucket for yourself. So I've already created one, but if you don't know how to do this, you can just click on create, give some name, random name, which is not used by any other user. Okay, just some random AI agent bucket. Okay, it was taken. You can keep all those defaults as is and just click on create. So I won't be creating this once again because I already have done that. Once the bucket is created, you can just upload the files that you want the agent to use. So I've again used the same file here, the same use case for the one that we did in the small agents one. Okay, the science class textbook. So why we are doing this? So because to build any agentic system, we need to have a data source. So once the storage is created, just go to agents, okay, Vertex AI agent builder. Okay, so before creating a agent, just click on the data stores because we need to connect the data store with the file we had stored in the bucket, right? So just click on create data store. If you don't have access to GCP, it's fine. You can just check this video later on whenever you have the access. Okay. Then choose the data source. Since we had saved it in cloud storage, click on this. The file was a PDF file, so this becomes my unstructured document. You can feel free to play around with this based on the file that you had uploaded. I'll just keep these as this. I need to browse the file, like where it was saved in the bucket. So I'll just expand this. I'll choose this and click on select. Okay, so I've already done this, so I won't be doing it again. And once this process is done, the data store will look something like this. Next step is to create an app for that. So go ahead and click on this apps button, click on create app. So when you click on this create app, you'll get some options. See what kind of app you want to build, whether it's a search and assistant kind of app, whether it's a conversational agent, whether it's a recommender system, and so on. So I'll just use a conversational agent here in this case, which is nothing but the dialog flow agent. You click on create. So again, I had already done this because to set up this process and to link the data source with the agent, it takes some time. Once that process is done, this is how you'll be seeing the apps listed here. So this becomes your app and this becomes your source. Okay. So once this is ready, just click on this and the dialog flow interface will open up. Okay, we have some questions. I'll be taking those after this. Okay, once this opens up, then just click on this test agent button and you'll see an interface where you can just put in your queries. I'll just try to put the same thing. Can you just tell me? Okay, I'll just take this one randomly. So this states key, there are three activities, three or four activities, or three or four things that helps us understand whether a reaction has taken place or not. So let me ask something similar. What are the observations that help me understand? This is the response: change in state, change in color, evolution of a gas, change in temperature. If I just go back, yes, the answer is correct. So yeah, so whenever you create an agent and create a data source, what happens is in Vertex AI agent builder, indexing happens on the data source that we had connected the agent with, and the indexing process takes for about 15 to 20 minutes. So that's why I had already created this for you. And yeah, it's giving me pretty much very perfect responses. I've given the steps. So in case you want to build this yourself on any data of your choice, then just check this out later. And yeah, that's it for the session. So we are very much excited to see what you build with AI agents. If you have any use case in mind or any projects that you have worked on, then feel free to share it on Twitter and mention the TFUG or ML Chandigarh team as well as me. And we have some resources for you as well. So if you just want to get started with building agentic systems, then these are the resources that I will recommend. So whatever I showed you in this session, that was just the tip of the iceberg. And a lot of things are still uncovered. So you can always go and check out these documentations and then see. So thank you so much. You can connect with me on these social media handles, and I'm open to questions now. Okay, let's start with this question. Can we make the LLM watch a movie and find plot holes or make a successor of it? What do you mean by this? We can anyways, use LLMs or VLMs for this in this case. He, you know, just check out this video and can we just, write an alternative ending to that or some kind of interesting use cases based on that? This is what you meant, Sagar? Make a successor in the sense sequel to that movie. If that's the question, then yes, You can ask the model key, just try to interpret what is the story or what is the plot in this movie, and then just try to, give a sequel to that. What distinguishes RAG from standard generative AI models? So when we talk about these vanilla models, when we say vanilla, these models are trained on, use, data of their own. Apart from that, if you ask anything else, they'll not be able to, provide answers. So for one instance, when we saw the example of the cricket match or the T20 World Cup instance of India, when was the last time India won the World Cup? Both the models gave us the wrong answer because it was not trained on the latest data, right? When we use an external data source, which was nothing but the web browser in this case, that is nothing but RAG. So RAG helps us, stay updated with correct data, correct information. So just for the sake of giving a response or the answer, the model can always go wrong from a standard point of view. Should we be scared of AI? No, we should not. In fact, we should use AI to simplify things. Yes, of course, AI agents in the future. See, there are systems that are, going in a feedback loop. Uh, let's say as a human, you provide some kind of feedback. Okay, this is not a, quite precise response that I was expecting. So you can set up a pipeline. The model is giving some responses. You as a human, evaluate that, or there are some automatic evaluators as well. So instead of you evaluating, there are other LLMs evaluating an LLM. Okay. So you set some benchmarks. This is what the expectation is, and based on that, the models keep on defining and keep on improving uh, in that loop. Can we summarize video using LLM? Yes, that's a very interesting use case, and that is indeed possible. What are the challenges and opportunities of developing AI that can learn and adapt more effectively as we need them to be precise when we telecast something live? Okay, so in this case, depends upon the use case that you're talking about. So if it is kind of, generating live captions, if that's what you meant, in that case, the model needs to be, quite precise. Whatever the person is speaking, for example, the language or whatever dialect that he's using, that should be precise enough. The model should be capable enough to, handle all those languages. That could be one of the things. And again, it's always a, good practice to have evaluations. So whenever something goes wrong, there is always a backup. You as a human, or we have a, system or an LLM that itself acts as an evaluator in that case. Knowledge-based AI, okay. Deep learning-based AI models. So deep learning-based AI models, these are complicated models, but when we talk about generative AI models, these are, built on top of DL models. So it depends upon what kind of use case you are talking about. So if you're talking about vision-based models, then we have object detection, classification, and so on, right? When we talk about knowledge-based AI, it can be anything, right? It can support any kind of data. It can take in PDF, videos, images, etc. And depending upon what kind of task you want the model to do. Okay. So as I spoke in the first slide, if I go back. So these days, when you talk about models like Gemini, it's quite versatile and it can do a lot of tasks for you. It can be analyzing a video, images, summarizing a text, and so on. Can we develop LLMs on normal processors without logging? Sorry, lagging. Okay. See, I don't see a need of creating your own LLM unless the LLMs that we already have are not able to solve your use cases. Okay, so what you can do, you can just take a existing LLM and fine tune it, customize it based on your use case. That's what we normally do, and that should work pretty fine for you. But yeah, to run, as the name suggests, it's large language model, so you do need some kind of processor, high-end GPU configurations to run that. if you're talking about local implementation, or you can always go ahead with cloud-based uh, implementation of that. Do you think we should be seeing platforms like Upwork for AI agents, where we can hire AI agents for tasks? Okay, pretty interesting question, but I don't think we should be using AI agents for everything. We can always have AI agents to solve some smaller tasks for us, particularly when we talk about very low risky tasks. But for tasks, or for things that we need to do ourselves, we should be doing that ourselves. So if it is a very simple or small, thing to do without any further risk, then we can use AI agents for that. That's my 2 cents on this, and again, it's up to you.
So, everyone, you can reach out to Mr. Nitin via LinkedIn. Well, that's a wrap for today's session. Thank you to our wonderful panel and to everyone watching. Your engagement and question make these discussions all the more meaningful. We hope you have taken away something valuable today. Stay connected, and we look forward to having you with us again in the future. Until then, take care and goodbye.